Section 3.2, Notes and Examples. Remember in a if-then statement that the if is what we know and the then is what we get. So if we know, we have a conclusion. So if we look at our first theorem, it tells us if two lines intersect to form a linear pair of congruent angles. So that looks like a linear pair. So we have our line, and our angles that we get are congruent. So our angles are congruent. So this is our given. And then our conclusion is going to be that the lines are perpendicular. So our conclusion would be that, let's call them line A and B, that line A is perpendicular to line B. And that's theorem 3.1. Theorem 3.2 says if two sides of adjacent acute angles are perpendicular, so this is what that looks like. Two sides of adjacent acute angles are perpendicular. So that would be the non-common sides are perpendicular. So let's call this A and B. So line A is perpendicular to line B. So this is our given. Create those two angles. Then the angles are complementary. So we will get our conclusion that angle 1 and angle 2 are complementary. And our third theorem says if two lines are perpendicular. So we begin with two perpendicular lines. So line A is perpendicular to line B. And there's 4 angles at those intersections. We get that they intersect to form 4 right angles. Remember, our definition says they intersect to create a right angle. This one gives us 4 right angles. So this means that angle 1, angle 2, angle 3, and angle 4 are right angles. So let's look at a few examples very quickly. So stating our reason, this picture over here goes with problem 1. So if we look at what we are given, we're given congruent and linear pair. And if we look back at what we just discussed, one of our theorems that we just discussed talked about having congruent and linear pair. So right here, if two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. And notice here's that perpendicular. So this is our theorem 3.1, a congruent linear pair gives us perpendicular. This next one is something that we did in our previous chapter. We have a midpoint and congruent. So this is our definition of midpoint. So remember that definition says a midpoint gives us 2 congruent segments. So here's our midpoint and the 2 congruent segments. The next one we've also seen in the past chapter. So we know the linear pair and we get supplementary. So this is the linear pair postulate that says that a linear pair, spell that right, linear pair gives us the supplementary. And then the last one is also from previous chapters. We have supplementary in this addition problem equal to 180. This is our definition of supplementary. So supplementary leads us to the sum of 180 degrees. Our next example is a proof of theorem 3.1 or 3.2. That means we cannot use that theorem anywhere within this process. Remember to start out with your given information. So our given information is here in line 1. So we're going to fill in given as our reason. This has that perpendicular symbol. So remember, we have a definition that says perpendicular gives us a right angle. So this is the definition of not right angle, but perpendicular. The next one says we need to use the definition of right angle. So this one tells us that the measure of the angle is 90 degrees. So that means the measure of angle DCE is 90 degrees. The next one is an addition problem. It's not supplementary or complementary because we don't have a number in this addition problem. But if we look, angle 1 and angle 2 are the parts, and this DCE is the whole angle in this picture. So this is our angle addition postulate. We're supposed to do substitution, and the only thing that I have in here twice is the DCE, so that means I can replace it with 90 degrees to equal the measure of angle 1 plus the measure of angle 2. And somehow this is supposed to lead to complementary. So remember that our definition of this talks about a sum of 90 degrees. So this is our definition of complementary. These problems, we're going to use our theorems to answer the question. So this one is theorem 3.2. We have a set of adjacent acute angles and perpendicular. So these two are supposed to be complementary. So x plus x equals 90. 2x is going to equal 90. So x is going to be 45 degrees. This is theorem 3.3. Perpendicular gives us 4 right angles. So that means x is a right angle. And that means that x is 90 degrees. And problem 3 is once again theorem 3.2. So when we have adjacent acute angles that have perpendicular sides, they are complementary. So the 2x for the first acute angle plus x for the second acute angle equals 90 degrees. 3x equals 90, so x is going to be 30.